us move to the next question, that is question number 75. A Zener diode having breakdown voltage equals to 15 volt is used in the voltage regulator circuit shown in the figure. The current through the diode is, so the voltage across the Zener diode is given to you. This voltage at this two terminal is given is how much? It's 15 volt. Now here also it's given 20 volt, that is the supply voltage from this 2 point. Now you need to calculate the current passing through this one. Now as we know, as the current goes from here, it gets divided into two parts, that is the current for IZ, that is the Zener current, and this current, right. This current moves through how much? 1 kilo ohm. So we can easily calculate 1 kilo ohm because we know the voltage, Zener voltage is given to be how much? 15 volt. So the current which we will get across 1 kilo ohm is easy because it's in parallel combination, right. So you can find out the current across this one, it's easily found out. So if I take this one as IZ and this one as I1 can be found out easily. Now you need to find out this one, right. Now find out this current I. This is the current I, right. Current I is flowing across, this is I1 and this is IZ. So I1 is known to you, IZ you need to find out, fine. So V equals to IR you have to do, or else you find out this current as I told you. Now this current can be found out, you have the potential difference at this point and at this point, you know that, and the resistance is given to you. So find out this current, and then finally I minus of this one will be your IZ. I minus of I1. I minus I1 will be equal to IZ, because according to Kirchhoff's law, I will be equals to what? I1 plus IZ. With the help of this one, you can solve this. So right answer for this question is 5 milliampere. Now let us move to the next question, that is question number 76. Out of the following, which one is not a possible energy for a photon to be emitted by hydrogen atom according to Bohr's atomic model? This is a question came from the chapter atoms, and the topic is Bohr model. So as we know, the total energy En is equals to minus 13.6 divided by n square. Now if you put the value of 1, 2, 3, 4 for n, the number of orbits, n as we know it is nothing but number of orbits. If you keep putting the value of n 1, 2 to 13.6 electron volt is possible. 0.65 exactly it's not coming out, but 0.85 is possible. 1.9 electron volt is not exactly 1.51 electron volt is possible, and 11.1 electron volt is a huge difference. This is a very uncommon one out of which. So this one will be the correct option, which is the wrong answer. Fine, this is not possible for an electron to emit, for a photon to emit energy of 11.1 electron volt. Fine. So now let us move to the next question, that is question number 77. In the following figure, the diodes which are forward biased are, which of the following diodes are forward biased? What is forward bias? This is a question came from the semiconductor physics. When positive terminal of the battery is connected to the P side and negative terminal of the battery is connected to the N side of the diode, then the diode is called as forward bias. Now we need to look at the option. Option number 1, this is at high potential, means it will be positive connected to the positive, negative connected to the negative. So option A is correct. This is forward bias. Now look at this one. This is at 0 potential, 0 volt, and this is at minus 10 volt. So this will be at high potential, positive connected to the negative. So no. Again, that is reverse bias diode. Now minus 12 volt and minus 5 volt. So this is at high potential, this is at low potential. Positive connected to the positive, negative connected to the negative. So this is also correct. Last one, this is at 0 volt and this is at 5 volt. So this is at high potential, this is at low potential. Positive connected to the negative, negative connected to the positive. This is a reverse bias diode. This is also not possible. So option A and C is the correct answer. Now look for the option C and A. Option number 4. This is the right answer. 77. Now let us move to the next question, that is 78. Two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. At time t equals to 0, number of P species are 4 n naught. That is initially n equals to 4 n naught. Okay, for radioactive nuclei P, and that of Q are n naught. Fine. Half-life of P for conversion to R is 1 minute, whereas half-life of Q is given to be 2 minutes. Initially, there are no nuclei of R present in the sample. When number of nuclei of P and Q are equal, the number of nuclei of R present in the sample, that would be how much? So one thing let me tell you, this is a question came from the chapter nuclei, where you have to use the formula n is equals to n naught e to the power minus lambda t. So you have one is n1, n2 will be equals to 4 of n naught e to the power minus lambda t. So these two will be equal, n1 into equals to n2. Just approach with this one, you will see that your correct answer for this question will be 9 n naught divided by 2. This is the right option for this question. So now let us move to the next question, that is question number 79. Pure semiconductor at 500 Kelvin has equal number of electron and hole concentration of 1.5 into 10 to the power 16 per meter cube. Doping by indium increases NH to 4.5 into 10 to the power 22 per meter cube. The doped semiconductor is of how much? So this n type you have to calculate, Ne you have to calculate, basically NH is given to you. For an intrinsic semiconductor, as we all know, this is a question from the chapter semiconductor physics. So we know that Ne into Nh is equals to Ni square. So once you know this, then you can solve this one. Ni is how much? 1.5 into 10 to the power 16. This is your Ni of whole square. Ne you need to calculate, Nh is given to you. So Ne I will keep here, Nh I will bring here. How much is Nh? 4.5 into 10 to the power 22. So let me see this one, 1.5 into 1.5 into 1.5 into 10 to the power 32 divided by 4.5 into 10 to the power 22. So 1.5 it will go 3 times, then 3 it will go 0.5 times, this one will go up, it will be 10 to the power 22, 10 to the power 10. 32 minus 1, this one will be 10 to the power 10, and 0.5 into 1.5, you just have to calculate this one. So your final answer for this one will be option number 2 if you calculate C. Okay. So option 2 is your right answer. Please see to it and find the answer. So this is all from this question. Now let us move to the next question, that is question number 80. A thin prism of angle 15 degree made of glass of refractive index mu1 is combined with another prism of refractive index mu2 1.75. The combination of the prism produces dispersion without deviation. The angle of the second prism is, so angle of deviation is same for both of them. So what I can write down is A mu, that is the refractive index, minus 1 will be equal to another one, that is A dash, that is mu 1, then this one will be mu 2 minus 1. This one is given to us, that is how much degree? 15 degree. If this is 15, then the refractive index for this one corresponding is 1.5 minus 1. A dash we need to calculate, and N2 is given to us 1.75 minus 1. So this is what we are supplied with. We need to calculate A dash. So simply you take this one at the denominator and find the answer, and the correct answer for this question will be 10 degree, right? So option number 4 is the correct answer. Okay. Now let us move to the next question, that is question number 81. Two identical piano wires kept under the same tension T have a fundamental frequency of 600 Hertz. They are having the same tension. So the fractional increase in the tension of one of the wire, which will lead to occurrence of 6 beats per second. when both the wires oscillate together would be? So this is a question came from the chapter waves, where the concept of tension and oscillations are being combined, and the right answer for this option will be 0.02. Please try this question out. It has got like little more bigger solution part. So I want you to solve this one by yourself, and let me tell you the right answer, that is 0.02. So this is the right answer for this question. Now let us move to the next question, that is question number 82. A small mass attached to a string rotates on a frictionless table top as shown. Okay, it's a frictionless table which is rotating. The mass is rotating. If the tension of the string is increased by pulling the string, causing the radius of the circular motion to decrease by a factor of 2, the kinetic energy of the mass will be how much? So here you have to use the concept of angular momentum, which is given by m v r is equal to constant. That is, the angular momentum is constant. So if you solve this one, the kinetic energy, if you find out, you will see that the kinetic energy will be increasing by 4 times of the kinetic energy. So the right answer is increases by a factor of 4. Number 1 is the correct answer. Now let us move to the next question, that is question number 83. The electric potential at any point x, y, z in meters in space is given as V is equals to 4x cube. The electric field at a point 1, 0, 2 in volt per meter is given by. So your electric field can be written as, from the chapter electrostatic potential, please remember that, minus del V by del X. V is your potential. When you use this formula, the correct answer will come out to be 8 along negative x axis. So this is the right answer. Now let us move to the next question, that is question number 84. 3 charges each plus q are placed at the corner of an isosceles triangle ABC of side BC, AC, okay, of twice A. D and E are the midpoint of BC and CA. The work done in taking a charge q from D to E will be how much? So out here the distance BC and AC are the same isosceles side, that is, they have the same side, and the charges are plus q. So at this point the potential will be same, and at this point also the potential will be same, right, as the distance is same. If the potential is same at these 2 points, the potential difference at D and U will be how much? 0. And if the potential difference is 0, work done will be how much? 0. As we know, this is a question from the chapter electrostatic potential. As we know, if the potential difference is 0, okay, that is V, D, E, so our work done will also be how much? 0. This is the right answer, because potential is equal to work done by charge. So if this is 0, then your work done will be how much? Work done will be equals to 0. So the right answer for this question is option number 1, that is 0. Now let us move to the next question, that is question number 85. A particle of mass m is thrown vertically upward from the surface of the earth with a velocity u. How much is the velocity? Velocity is u. The mass and the radius of the earth are respectively m and r. G is gravitational constant and small g is acceleration due to gravity on the surface of the earth. The minimum value of u so that the particle does not return back to earth. What does it says? First of all, this is a question from the chapter gravitation of class 11. It says that you have to throw the particle in such a way that it escapes the gravitational pull. So u is your escape velocity, and the expression for escape velocity is direct. We know the derivation is there. Look for the videos. It is root over of twice g m divided by r. So we will see in the option which one is the correct answer. Option number 3 is your correct answer. So this is the right answer for this question. Now let us move to the next question, that is question number 86. A short bar magnet of magnetic moment is given to be 0.4 joule per Tesla, is placed in a uniform magnetic field of 0.16 Tesla. uniform magnetic field. Remember, the magnet is in stable equilibrium. When the potential energy is stable equilibrium, means the angle between the magnetic field and the magnetic moment will be how much? 0 degree. Please see the videos nicely. So, potential energy can be written as minus mb cos of theta. Your m is the magnetic moment. It is given to be how much? 0.4, and b is given to be how much? 0.16 multiplied with cos of 0 degree. Cos of 0 degree is 1. Once you solve this one, your right answer will come out to be 0.064 joule. That is option number 3. Now let us move to the next question, that is question number 87. A square loop carrying a steady current I is placed in a horizontal plane near a long straight conductor carrying a steady current I1. This is the long straight wire carrying a steady current I1 at the distance d from the conductor as shown in the figure. The loop will experience what? So, what this loop will experience when it is moving, when the current is moving in a clockwise direction. So, a net torque acting downward normal to the horizontal plane? No. A net attractive force towards the conductor? Yes, this can be. If you find out the force due to the parallel conductor, when both of them are moving in the same direction, if you use Fleming's rule, you will see that the two wires will have an attractive force towards each other. So, option 2 is correct for the time being. Now, let us see the other options. A repulsive force? No. A net torque acting upward perpendicular to the horizontal plane? No. So, option number 2 is the correct answer. Now, let us move to the next question, that is question number 88. A projectile is fired at an angle of 45 degree with the horizontal. The elevation angle of the projectile at its highest point as seen from the point of projection is. At the highest point, how much is the elevation angle can be seen? So, for that we have to know how many phi's will be there. This is a question from the projectile motion. So, I can solve this one, or I can tell you to apply this. Tan of phi plus tan of phi is equals to tan of theta for both the side. So, it will be twice tan of phi is equals to tan of 45 degree. So, your tan of phi will be equals to half. So, your phi will be equals to tan inverse of half. So, this is a direct question, so I have solved it for you. So, option number 4 is the correct answer. Now, let us move to the next question, that is 89. A coil has resistance 30 ohm and inductive resistance 20 ohm at 50 hertz frequency. If an AC source of 200 volt 100 hertz is connected across the coil, the current in the coil will be how much? Okay, now this is a question from the what? From the topic alternating current. How you are going to approach this one? For that, you need to find out the impedance at first. Once you calculate the impedance, you can directly use the formula V is equals to IZ. So, your I will be equals to V by Z, and your V is given how much? 200, and you will see that your Z is coming out to be 50, this value. So, the right answer for this question is 4 ampere. So, this is the right answer. Fine. Now, let us move to the next question, that is the last question, 90. The density of a material in CGS system of units is 4 gram per centimeter cube. In the system of units in which unit of length is 10 centimeter and unit of mass is 100 gram, the value of the density of material will be how much? Now, let us find out this part. This is a question came from the chapter units and measurement of class 11, and let us see how to solve this one. So, this is how you will solve this one. So, if you do the solution of this one, it will be 4 of G divided by centimeter cube, that is 4 gram per centimeter cube, which is given in the question. So, we need to find out this x, which will be 100 gram, right, divided by 10 centimeter of whole cube. So, your x will come out to be 40. So, the correct answer for this one is option number, if you see, is 40. This is the right answer. So, this is all we have from this question paper. Fine. So, I hope you will see the topics and then do the numericals. It will help you. Thank you.